why'd you start exploring alternatives to cancer drugs? You started briefly talking about it. Maybe you could talk about the grenade approach.
Well, our approach is pretty different. So, there are many different approaches to cancer, and you'll hear me talk about personalized medicine in many different ways. But the approach that we have with our drug that's in clinical trials right now called mipsigargen, it's not a good name, but we'll get a new one when we have a brand name, and but generic names are always hard to pronounce. The idea actually started in prostate cancer, where I have a background and my colleagues at Hopkins do. And standard chemotherapy that kills dividing cells and gives you all those nasty side effects doesn't work well in prostate cancer because prostate cancer divides slowly. So it's a simple question that they had is, can we kill those cells when they're not dividing? And of course, through research, the answer is yes if you upset calcium levels. And there's this natural product from a plant that grows in the Mediterranean that does exactly that. So it was a marriage of these prostate cancer guys at Hopkins saying, can I do this? And a basic researcher at the University of Copenhagen, by the way, they're all on my science advisory board now, that found this molecule in nature that upsets calcium. So now the issue is, can we deliver it specifically to the cancer cell so that it will die because this plant-based toxin kills everything. And so the idea is, let's make a little molecular grenade. Everyone knows what a grenade is. It's a bomb and a grenade pin. It's real simple. We have a better bomb. It's the cytotoxin from a plant. And then the grenade pin is a small molecule that we attach to it that's designed to keep it inactive, but is designed to be recognized and then removed specifically by a protein that resides only within the tumor. So it floats around the body, innocuous as could be, gets into the tumor pulls a grenade pin, the bomb is released. It happens over and over and over again until you get enough bombs that you kill the tumor. The bomb is insoluble, it doesn't come back into the bloodstream to cause toxicity elsewhere in the body. And it sounds really science fiction-y, it's a pro-drug, meaning it's activated only within the tumor. It actually works this way. We demonstrated this in a whole bunch of animal models, now we're demonstrating in humans. That's why you get the efficacy and the side effect profile. It works as designed. But I can tell you, I took this to my former employer to in-license it from Hopkins and work on it, and all the other VPs told me no, it'll never work, it's silly, it's nonsense. So when you say, how do things happen? I had to be brave enough to say, okay, I'll do it. And set up a new company, which I never did before, I was a scientist, and say, we'll make it happen. And that's the path, but the belief in it from myself and others that join in and participate is just extraordinary. It's really exhilarating, especially at the point now where we have clinical data.